Okay, hey guys, so in this video series, we will be solving problems from Daniel Klepnner and Kolenkow, and this is the first video in the series from chapter 2, that is Newton's laws of motion, and this is the first problem. So what the problem says is that I have a mass of 5 kg which moves under the influence of this force, that is time-dependent force, and what I need to find, and it is at rest. It starts from rest and it is at origin at t equals to 0. So initially it is at origin and it is at rest. Very good things. So I want to find its, I want to find its velocity, its position, and this quantity r cross v vector at any time, right? T. So let's solve this problem, right? So for but I have this force. Let me just write it down as f vector as 4t squared I cap minus 3t of j cap newtons. So, and from here I want to calculate its acceleration vector. It will be just f vector divided by m, that is 1 upon 5 4t squared I cap minus of 3t j cap meter per second square, right? And from this I can actually calculate my velocity, and that is my first part. So velocity will be v vector at any time t minus of v at 0 is equals to integral from 0 to t acceleration as a function of time dot dt. So it will be just 1 upon 5 integral 0 to t 4t squared dot dt I cap. Oh, okay, let's just not do it like that. Yeah, so it will be 4t squared I cap plus 3t j cap dot dt. And now if we do the component wise integral, it will come out to be 1 upon 5 4 by 3 t cube I cap plus 3 by 2 t squared j cap meter per second. And now the thing is, I know that at time t equals to 0, this thing is equal to 0, so I can just write it as v vector as a function of time equals to 1 upon 5 4 by 3 t cube I cap plus 3 by 2 t squared j cap meter per second, right? And now the second thing is I need to calculate is its position. So v vector is further can be written as dr vector upon dt vector is equals to your v vector as a function of time. And if I want my r, so I can write it as r vector as a function of time at any time minus of r vector at time et equals to 0, and the integral from 0 to t of this quantity. So I'll just copy it or paste it here. Let me copy, paste. Okay, so I'll just integrate this thing. I'll take out this note here, and it will be dt here. Okay, so it will be yeah, so it is a bit hectic one, but anyways we can do it. So you try it. It will be 1 upon 15 t to the power 4 I cap plus 1 by 2 t squared j cap, sorry, t cube j cap. Yeah, so it will be t cube j cap. This thing over here, okay, this 3 will go to 4, and 4 and 4 will cancel out. This square will become 3, and again 3 and 3 will cancel out, and you will get this result. And at last I can write meter there behind. Now the last thing is I want to calculate. So let me just highlight this results. This one thing and this is one thing. Now let me just highlight the results. It's the last thing I want to calculate. The C is that my R vector cross V vector. This quantity I want to calculate it at any time. So yeah. It's I, J, K. I will write it as so it will be 4 by 15. 4 by 15. Okay, I need to first write the R cube thing. It will be 1 by 15 t to the power 4, 1 by 2 t cube, and 0. So again it will be 0, and this will be 4 by 15 t cube, and it will be 3 by 10 t squared, right? And now let's do it. So my R vector cross V vector will be okay, just take the cross product of it, so it will be 0 I cap plus minus of 0 j cap and plus. Now it will be a bit something. Okay, so it will be t to the power 6. Just hold on. 50 minus of 4 t to the power 6 upon 30 j cap. Let's take it will be okay, let's take t to the power 6 outside. It will be 1 upon 50 minus of 2 upon 15 k cap. I'm not reducing it any further. So this was the solution of the problem. Hope you liked the video, and let's see you in the next videos. Bye.